Assalamualaikum. Boleh dengar? Assalamualaikum, boleh dengar?
Salam, boleh Prof.
Okay. Okay, we continue our lecture by looking at the proportional controller. Can you see the slide? Can you see the slide?
Yes, can.
Okay, as you know that controller is used to control the performance of a system. So this one is not included in the subjects, okay? Because 3133 is just for modeling and simulation. So for controller, you will study next semester 3143, which is a control system design. Okay. So at the moment we are focusing on this. Okay, but nevertheless, we have a controller which is connected cascade to the process, okay, which is known as proportional gain. So this one that you practice in the laboratory, okay, 3722, where you have to adjust the gain so that the system is become stable. So in reality, proportional gain is the variable resistor. Okay, which you can vary the value of the resistance, okay, accordingly to achieve the targeted gain value. So the proportional controller is one example where it can be changed the location of the poles of the overall system. In my last week lecture, okay, I did change from K value from 3, 4, 5, 6, and 7. You can see that the value will affect the stability of the system from stable to unstable, from unstable to marginal stable. So this type of controller is known as a gain controller, okay, or proportional gain. Or in short form, we call it as a P controller. Okay, by just changing the value of K, so the system performance can be changed since the closed loop poles location also change, okay, when the gain is varying. So this will affect the stability of the system and hence implying the K that has a certain range for a system to be stable. Meaning that we can set the range for K for minimum and maximum to achieve stability. If the K value is it's not between minimum and maximum, so it's considered as unstable. So this can be achieved by using Roth-Weiss criterion, okay, to achieve the stability. So in your design, okay, in your design of the transfer function, in assignments, please include this Ruth-Lewis criterion in one slide of the stability chapter. Okay. So we go for examples. Find the range of K that will cause the system to be stable, unstable, and marginal stable. So this one in the box is the GS. Okay, the open loop transfer functions. Okay, so in order to find the status of the closed loop system stability, so we have to find the closed loop transfer function. Let's take STS, and then this one will be K S plus 7, S plus 11 plus K. So this one is known as the closed loop transfer function. And from the closed loop transfer function, we can obtain the characteristic equation, which is, what is the characteristic equations? Nur Aina?
Yes, Prof.
What is the characteristic equations for these examples?
S
Baca lah, yang I
Okay.
tulis.
plus 13s squared plus 77s plus k equals to 0.
Okay, equal to 0. And this characteristic equation, the coefficients, okay, the coefficients will enter to the mana? Will enter to Roth-Lewis table. Okay, which is here 1, 18, 77, and K. Right? 1, 18, 77, and K. So how do I get this one? Zulfika. Zulfika,
Yes, Prof.
how I get this one?
Matrix. Determinant.
Lagi?
77 K.
Divide by?
Over 18.
Simplify?
1386 minus K.
77, 18 berapa?
Wait. One three eight six
Divide by?
18.
So 1386 minus K divided by 18. So that's why we get this one. Okay. And this is 0. Okay. So that is 0. And then this one is become K. Can become K. Right. So the theory, what is the theory of Roth-Lewis for stability? Zairi Ilham.
Yes, Prof.
Teori dia apa? First column,
No change.
first column, mass greater than 0 for stability.
Stability.
So 1 is greater than 0? Yes.
Yes.
18 greater than 0?
Yes.
Yes. But this one, you have to find the range. Okay. So 1386 minus K divided by 18. Okay. 1386 minus K over 18. Over 18 greater than 0. And so this one will become 1386 minus K greater than 0 minus K greater than minus 1386. Then opposite signs 1386. Okay. So this is number 1. Number 2 is this one. Ni, K. And so K is greater than 0. So from here, we found that there is a range. Okay, ni ada range. We can create equation of range. So what is the equation? Aisha Shahira? Aisha Shahira?
Yes, Prof.
What is the
It's between 0 to
Hmm?
1386.
1, 3, yes.
86.
Okay, so this is the range. Range of what? Range of apa Syarah? Range of
Stability.
range of stability. Okay. And then that is number 1. Number 2, okay. Number 2 is what? No sign change. Okay. So meaning that if no sign change, 0, right, half plane poles. Okay. There is no poles on the right half plane. So only 3 left half plane. There is no special case. So special case meaning there is no imaginary axis. Poles at the imaginary axis. So system is stable. If K greater than 1386, so we will find that 2 sign changes and 2 right poles, and it cause you unstable. Okay. If K is 1386, ROZ appears, row of zeros. So meaning that we have a poles at the imaginary axis. So you can see that from here, okay, K1385, stable, correct? K1390, unstable. K exactly same, 1386, so system will be marginal. So please remember and try to understand this equation of range. And Rita, do you understand?
Yes, Prof.
Tak dengar ba?
Hello, Prof. Can you hear me?
Tak dengar, tak dengar. So this is when K is equal to 1386. So it happens that column is equal to zeros. Okay, so you can see that there is no sign change. Okay, meaning that 2 poles on the imaginary axis and 1 left hand pole, which is a marginal stable system. Yeah, dia begini. Okay. .3. So this is your GS, open loop transfer functions. Okay. So what is the TS? Closed loop. Sakari? Absent. Hafiz Nazim? Closed loop transfer functions?
Yes, Prof.
closed loop transfer function. K S plus 20 S plus 2 Peace
Hello.
S plus 20. Okay, so that is the closed loop transfer functions. Rida Hadira,
Yes, saya, Prof.
characteristic equations.
S.
S cubic
Okay.
5S square
First, plus
6S
6.
plus KS plus 20K equal to 0.
0.
Okay, so this one can be simplified. Third, Rida Hadira. Third, I simplified this one.
Yeah. Boleh.
So what is the coefficient, Rida? 1, 5, 6 plus K,
20.
20K. So we take this coefficient, we plug in into the Roth-Swiss table. Okay. This one is closed loop. So 1, 5, 6 plus K, 20K. How do I get this one? Nur Najwa,
Determinant
Eminem,
1, 5, 6 plus K 20
divided by
over
5. Okay. So we get this one. Then continue 20K. Najwa Atira,
Yes, Prof.
what is the theory of Roth-Swiss for stability? First column,
Must lie on left half plane.
is greater than.
Greater
Zero.
than 0.
Okay. So 1 is greater than 0. Najwa Atira, 1 greater than 0.
Yes.
5.
5, yes.
So we have 2 unknown there. Okay. Can you read for me the unknown?
30
30.
minus 15K.
13 minus 15K
15K.
divided by
5. Kuat tadi.
5 quote.
Saya ingat.
Greater than 0. Simplify. Greater than 0.
Two.
Go ahead. Equation 1. The second one, 20K greater than 0. Correct.
Yes.
So what is the range equation?
Between 0 and 2.
0 K and 2. Okay. Shakila? Shakila? K equal to 1. Stable or unstable? K equal stable. Tak dengar. K equal to 3. Stable or unstable?
Unstable.
K equal to 2. Stable or unstable?
Unstable. Unstable
Alah.
atau
K
bukan?
equal to 2.
Oh, marginal. Oh, okay.
Okay. Question number 13. Find K and E if the closed loop system is marginally stable. Okay. Marginally stable and the natural frequency omega n of the output is 2 radian per second. Okay. Daniel? Daniel,
Yes, Prof.
can you read for me the GS?
K
Hmm?
bracket S plus 1 over
Hmm?
S power of 3 plus A S square plus
A?
A
S.
S square plus 2S plus 1.
Tu je?
Yes.
Daniel? This one is open loop, eh? Daniel?
Yes.
Close loop?
Let's loop K S plus 1 over S power of 3 plus A S square plus 2S plus KS plus 1.
So the characteristic equations. Saibal,
Yes, Doctor.
characteristic equation.
It's S cubed plus A squared plus 2S plus KS plus 1 plus K.
This one?
Yes.
So the coefficient is 1, A, 2K plus 1 for S and 1 plus K for S power of 0. So that's why, okay, 1, A, K plus 2 and K plus 1. Okay. Understand? Understand, eh?
Yes.
So how do I get this one? Fatihah,
Yes, Doctor.
how do I get this one?
Determinant
Negative?
1, K plus 2, A, K plus 1
Divide.
over A.
Okay.
Equal
Right.
to that.
Then K plus 1.
Uh-uh.
So we take this one, K plus 2 minus K plus 1 equal to A equal to 0. We assume the system is marginal stable, ROZ. Okay. So we can find the auxiliary equation, which is on the top of it, AS square, K plus 1 equal to 0, where omega n is given as 2. Okay. So S is equal to J omega. Okay. So omega n is equal to 2 given. So we insert the value. Okay. We insert the value of omega n. And then we can find the value of K. Okay. So I leave it to you for further solutions. Okay. So omega n is equal to 2. So you insert inside the questions, then you get K value. So end of lecture 5. So we are officially finished our syllabus for this chapter. Okay. So now we are going for revisions. Okay. Revisions for final exams questions. Are you ready? Are you ready? Guys, are you ready? Hello? Hello?
Ready. Good.
Very good. Okay, look at question, the one that I WhatsApp you. It is 2013 and 2014. Okay, yeah. Semester 1 is in January. Okay, the exam is on January. Your exam will be on bila? 3133, the draft final exam table.
15.
Huh?
15.
15. 15 eh? 15 January.
15 February.
15 February. Okay. So the format is different for this subject during the pandemic. So let's go to question number 5 first. So question number 5 is no need to answer because it's out of syllabus. So this one is syllabus, it goes to 3143 next semester. Okay, so we go for question number 4. So this question number 4 related to chapter 5. And this chapter 5 will be, we'll have a quiz on the 23rd of January. Quick quiz. Quiz 3. Okay, Aisha Akram, can you read for me question number 4 as depicted in your laptop?
Question 4A. Briefly discuss 3 main objectives in designing a control system.
Continue.
B. Consider the position servo mechanism used in antenna tracking system as shown in figure Q4B. In this system, an electronic motor is used to rotate a right. Electric motor is used to rotate a radar antenna which automatically tracks an aircraft. A unit step input is used to investigate the performance of the antenna tracking capability.
Okay.
1. Prove that the closed loop transfer function of the system is Cs over Rs equal to 0.4K over 0.8S squared plus 2S plus 1.2 plus 0.4K. Second, find the natural undamped frequency omega n and the value of the K to produce a critically damped response.
This one, like
Find this.
the last example.
Third, find the steady state error ESS of the system by using the value of K obtained from B second above.
Next.
C, a plan with the following transfer function is controlled by a professional controller as shown in figure Q4C. GS is equal to 1 over S bracket s square plus 2s plus 2 bracket s plus 3.
Okay.
First, discuss the stability of the closed loop system based on the Roth-Hurwitz criteria.
Ralph.
Ralph with
Ralph.
Ralph with saya pakai pencil from sana. Dia ada dia tak payah nak pusing, dia mulut saya ni ke depan. Ralph with criteria determine the range for the proportional controller gain K for the system to be stable. If the system is marginally stable, determine the oscillation frequency of the system.
Thank you very much. Sorry. All right, solutions. Q4 2013 14 Boleh? Guys, boleh? Tak semangat dia budak-budak ni. Boleh guys?
Boleh, Prof.
Yes. Okay, the teori tu. Main objective in designing a control system. Balkis?
Doktor, rumah Balkis tak ada elektrik, jadi dia tak dapat join. Tadi dia dah bagi tahu.
Soleha?
Sorry?
4A. Teori tu. The main objective in designing a control system. First, baca lah.
Fast transient response,
Number 2.
stable system,
Stable. Keyword dia apa? Stable
yes,
Yang ni fast transient response. Keyword. Next.
zero steady state error,
0 or steady state. Lagi. That's all.
yes,
Tambah lagi satu. Shorter settling time. Settling time shorter. B. Okay, so in B, you have two feedback. One internal, one external. Okay, so like this one is similar to the laboratory, kan? Ada dua position control. Satu velocity feedback, satu lagi adalah feedback. So what is the transfer function for the internal loop? Azri Rukaini. Datang. Azri Rukaini. Datang Jenal? Jenal Arif?
Yes, Prof.
What is the transfer function of the internal loop? Dalam
Transfer function
of the internal loop.
uh, 0.2 over 0.8s plus 1.
Yeah.
Plus
Including the feedback lah. So it will become 0.2, 0.8s plus 1.2, correct?
Yes.
And then the open loop transfer function, Aisyah Shahira. Tak datang.
Open
Open loop transfer function, cascaded. Oh, not cascaded.
key times 0.2 over 0.8 s plus 1 times with 2 over s plus 1.
Okay, simplify. Shahira, simplify.
0.4 key over 0.8 s plus 1 times with s plus 1.
So 2s lah. Betul?
Yes, betul.
Correct. Betul tak?
Tak nampak, Prof.
Tak nampak. Dekat bawah. Okay.
Dia macam kad. Okay.
Yes, dah nampak. Nampak dah.
Nampak Syahira, nampak? Betul tak?
Nampak, betul.
Betul. And then characteristic equation. Characteristic equation. This one is open loop kan? So closed loop nya. Herman?
Yes, Prof.
Closed loop.
Tengok balik. Okay. 0.8 s square plus 2s.
Mana ada 0.8? Open loop. Sorry, closed loop transfer functions. 0.4K dulu bang.
Oh, okay.
Kamu mimpi kah?
Square plus 2s plus 1.2 plus 0.4k.
Ya, betul. Sama tak? Is it same like the questions? Is it proven? Hello?
Prof.
Okay. Next question ya, Pak. Tiga markah. Tadi itu? 3 markah. Okay, next. Find the natural undamped omega n and value of k to produce a critical damped response. Nabil. Oh, Nabil.
Yes, Doktor.
Critical damped response tu apa?
Critical damped response, Doktor. Alamak, Doktor. Ya.
Alamak. Datanya berapa? Data tu apa?
Data tu dapat daripada.
Data tu apa?
Data tu adalah. Tak tahu, Doktor.
Astaghfirullahaladzim. Jahanam budak-budak ni. Damping ratio, cuba sebut.
Damping ratio.
Jadi bila critical damp zeta sama dengan
Critical damped zeta sama dengan 0, Doktor.
oh ya, kena debit tu. Wahid sama dengan apa?
1.
1.0. Nasib baik.
Terima kasih, Doktor.
Ingat tu sampai mati ingat. Then what is the equation itu? Omega n square s square plus 2 zeta omega ns plus omega n square. Kan? But the transfer function yang kita dapat is, tadi apa Herman? Yang kita dapat tadi apa?
0.4k over 0.8s square plus 2s plus 1.2 plus 0.4k.
Tapi masalahnya, yang ini kita tak boleh compare ni. Kan? Jadi 0.8 ni kita kena eliminate. Menurut Najwa, macam mana kita nak eliminate 0.8 tu?
Factorize.
Ha? Apa? Tak dengar.
Divide with 0.8.
Divide by 0.8. Jadi 0.4k divide by 0.8. Am I right? S square. 2 bagi 0.8 berapa? Najwa? 2 divide by 0.8.
2.5.
Ha?
2.5.
S plus 1.2 0.4k divide by 0.8. Dan barulah kita boleh compare dengan yang ni. Enggak. Sebab tapi zeta equal to 1. Ni. Zeta equal to 1. Okay. So now it become 2 omega n lah. Boleh? Boleh tak? Can or not? So how to compare?
Can.
Henrita, how to compare?
Yes, Prof. How to compare?
Compare lah. Compare.
2.5 equals to 2 omega n.
Jadi omega n berapa bang?
Jadi omega n omega n
Ya, omega n sama dengan 2.5 divided by 2.
Yeah.
1.25. Betul?
Yeah, 1.25.
Oh. Omega n square berapa, Henrita?
Omega n square 1.5625.
Huh?
1.5625.
1.56.
625.
Okay, which is equal to
1.56.
no, equal to apa ni? Ni.
Oh, equals to
0.4 divided by 0.8 berapa?
0.5. 0.5k.
Tak. Bukan yang ni. Yang ini. Kita ambil yang ini. 1.2 divided by 0.8 berapa?
1.5.
0.8 divided by 0.8. 0.4 divided by 0.8.
0.5.
Okay. Okay. Now this one equal to omega n square. Okay. So 1.5 plus sama dengan, okay. So K berapa? K berapa? 0.125.
125.
Okay. 5 markah. Next is the steady state error. So K is equal to berapa tadi? 0.125 So what is the steady state error? Okay, so steady state error is formula lah. S to 0 SES error, yeah, which is equal to ES apa? ES is RS input divided by the RS is one step, 1 over S because of one verb. So that's why the steady state error is 1 plus limit S to 0, 0.4K, 0.8 S square plus 2S plus 1.2. Okay. One plus 0. Okay, so masukkan K. K tadi is 0.125. So steady state error is equal to 0.96. Okay, 4 markah. Part C. Okay, so part C, we have a open loop transfer function GS. Okay, so we have to discuss the stability. So for part C, K S square plus 2S plus 2 S plus 3. Boleh tak you simplify kan dia? Can you simplify the denominator? S power 4 plus 6S. Okay. So this is an open loop. Closed loop. K plus K. Okay. And the characteristic equations. Okay. And the coefficients 1, 5, 8, 6, and K, we insert into the rough table. Okay. Which is S power of 4, S power of 2, S power of 4. Okay. So it will be 1, 5, 8, 6. 1, 5, 8, 6. K 0. Okay. Hmm. Seven. Ramai tak datang eh. Afzal. Afzal.
Ya, Doktor.
Ni berapa?
Ya, Doktor.
6.8 kot. Okay. 6.8. Yang ini K 0. Yang ini adalah 40.8 minus 5K divided by 5. Okay, this one is 0. And lastly, this one is K. So ditanya, in the part 1, discuss the stability of the closed loop system based on the Roth-Lewis table. So the theory said that first column must greater than 0 for stability, correct? Okay. So 1 is greater than 0, 5 greater than 0, 6.8 greater than 0, but this range need to be simplified. So 40.8 minus minus 5K divided by 5 must greater than 0. Afzal, dah dapat dah?
Tidak tu?
Dah dapat?
Sekejap.
Lama ni. Ni, tolong.
Sekejap.
40.8 divided by 5, berapa?
8.1C.
8.1C.
Yes,
Okay.
betul.
And then this one is equation 1. And another one is K greater than 0, equation 2. So that's why the range of stability is 8.16. Betul? Betul tak? Guys, betul tak?
Betul, Prof. Betul.
Oh,
So for marginal stable conditions, okay, marginal. Shakila?
Yes, Doctor. 8.1C.
Berapa? For marginal
8.1C.
8.16. Okay. 8.16. So 40.8 40.8 ni minus 5K, okay, divide by 5 greater than 0. Kan? Betul tak? 8.16 So you dapatlah K 8.16. Okay. And then for the equations, which is equations of this, equation ni 6.8 S square 6.8 S square plus K equal to 0. S equal to J omega. Okay. So you will get 6.8 S square plus K 8.16 equal to 0. So S square minus 8.16 divided by 6.8. Berapa ni? Shakila? 8.16 divided by 6.8.
Negative 1.2.
Negative 1.2. So S is equal to square root berapa?
Negatif tu tak ada dengan Doktor.
Yalah. Jadi J lah.
1. 0.095.
Huh?
1.095.
Square root 1.2.
Uh-uh.
0,
95.
5. S is equal to J omega. So J omega equal to J 1.095 kan. So that's why your omega n is 1.095 radian per second. So that's dah habis. 11.55. Nur Janjo lah, faham tak?
Faham. Tapi doktor, nak tanya.
Boleh?
Dekat yang rough width table tu kan, untuk fourth row, dia sepatutnya divide 6.8.
Mana?
Yang dekat S power 1.
Ni. Ni.
Bawah.
Bawah.
Yang 40.8 minus 5K over 5 tu sepatutnya divide by 6.8 kan?
Divide by 6.8. Formula 6.8 Apa? Divide by apa-apa pun tetap kosong.
Okay.
Tak kosong. Silap lah. Divide by 6.8. Ni kan? Ada soalan? Balkis? Tak ada? Kehadiran?
Rumah tak ada elektrik doktor.
Ya, memang di situ memang ada problem. 39 out of 51. So 11 students absent. Okay, thank you very much. So I see you on Wednesday, inshallah. Okay.
Thank you, Doctor.
Thank you, Prof.
Okay.
Thank you, Prof.
Thank you, Doctor.
Thank you, Prof.
We'll give you the 9 set
Uh,
PDF later. Thank you.
Thank you, Prof.